Thank you, David, and thank you, Dirk, for this Q&A session. We had some technical problems with the chat box and questions box, so please continue to write your questions for our speakers and engage in the chat box if you have the chat box. So now I would like to move to our academic panel and invite Arvind, David, and Tian. So Arvind is a professor in the Paul Allen School of Computer Science and Engineering at the University of Washington. Do we have Arvind here with us? Hi, Arvind. We have also David, who oversees technology offerings in the University of New Hampshire InterOperability Laboratory. Hi, David. And we have Tian, who is a research scientist at the Materials Research Laboratory and Department of Materials Science and Engineering at MIT. Hi, Tian. So welcome all, and to start, I would like to have a short presentation of you. Can you please tell us a little bit about your background, your research, and where are you coming from? So let's start from David, please.
Yeah, so I'm David Woolf from the University of New Hampshire InterOperability Lab. That's a lab within the University of New Hampshire. So I'm not coming at things from the academic side. Rather, we work with students mostly in training them about testing technologies for data communications. So really what our lab is a neutral third-party compliance and interop test lab based at the University of New Hampshire up here in the northeastern United States. And we serve a number of different technology communities. That goes from networking, local area networks, testing electrical signaling for low-level Ethernet PHYs, all the way up the stack to IPv6. We test time-sensitive networking, broadband networks. We've worked with OCP in the past on doing some testing for interoperability with the networking group. We do a lot of testing with storage technologies. That's actually what my background comes from. Also Wi-Fi, PHYs for mobile devices, inside devices, and also PHYs for use in automotive networking. And as Leslie mentioned, my role here at UNH-IOL is overseeing our technology offerings. So that's helping our teams determine how best to meet the needs of a community that they happen to be working with, and also leading efforts for us to engage with new technology communities. And that's why this event is actually so interesting for me, because at its core, what UNH-IOL does is collaboration, where interoperability is making things work together. So collaboration is really in our DNA. And it's not just the collaboration for our internal teams, it's collaboration with external communities, collaborating with organizations like OCP, like IEEE, like IETF, like the Broadband Forum, different coherency groups that we've been talking to recently, as well as individual companies that have their own schedules and product roadmaps and resources that they bring to the table. And so much of the kind of engine of that collaboration that we would do was face-to-face. And so figuring out the next steps and how we do that moving forward is really interesting for us. That's why this event's so interesting to me. And I'm really excited to see what other folks have to share.
Yeah, thank you so much. So Arvind, you're a professor at the University of Washington. Can you tell us a little bit more about yourself and your research?
Yeah, definitely. Thanks for having me on the panel. So I'm at University of Washington in Seattle, and we a pretty large computer science department. It's actually recently became the Paul Allen School of Computer Science with about, I would say, 70 or so faculty members. I think our annual kind of undergraduate student population is about 400 students. We graduate every year. We have about 250 PhD students, and we have a couple of different kind of master's programs, such as professional master's programs. And I personally have been at University of Washington for about 15 years. I work on networks and distributed systems, which is actually pretty related to the kind of topics which OCP is very interested in. In particular, the area of research that many of my students and my colleagues in my group work on has to deal with data center networks, wide area networks, what to do with, for instance, new hardware. For instance, I would say the kind of research topics that we focus on kind of falls into one of three buckets. One is new hardware keeps coming out. Some of them is more programmable. For instance, you have programmable NICs, programmable switches. How do we take advantage of this new hardware is kind of one of the key areas of focus. Another thing that we work quite a bit on are cloud applications, such as distributed storage, distributed transactions on top of distributed storage. How do we make it more efficient? Finally, we also focus quite a bit on systems for machine learning, which encompasses all aspects of ML performance, starting from training to inference and making that much more efficient. So essentially, our group, more specifically, I think the thing that I would like to focus on is actually the research activities of our group. So we have a group of about 30 or so students with about 6 to 10 faculty members working on these areas on networks and distributed systems. And the things that I would like to share over the next 15-20 minutes is really how the research aspects have been affected. Clearly, we heard quite a bit about how teaching has been impacted. Interestingly enough, I'm on a sabbatical this year, so in some sense, I've been shielded quite a bit with respect to how teaching has been affected. But again, sort of tell a bit about the research aspects.
Yes, thank you so much for your wonderful introduction. So Tian, real quick, can you just tell us what do you do at MIT?
Yeah, sure. Yeah. First, thanks for organizing this great event. So hello everyone. My name is Tian Gu. I'm a research scientist from Material Research Laboratory at MIT. I'm also the co-investigator of the photonic materials research group. So our group's research focus is basically focused on optics, photonics, and photonics materials in multiple areas such as data communications, imaging and sensing, flexible photonics, 2D material integrated photonics, and energy conversion, and so on. So we actually have been involved with the OCP community for a few years, and we're one of the first best paper awardees of the Future Technologies Symposium. There have been actually a lot of synergies, supports, and inspirations from the symposium. So I think this is truly an ideal platform for interconnections between academia and industry. So one of our projects that is related to the symposium is a on-chip optical interface platform for high-density, energy-efficient photonic packaging and optical interconnects for future data centers and high-performance computers. Basically, our approach is based on a free-form optical coupling scheme for seamless interfacing between optical fibers and on-chip waveguides. So compared to the existing edge or grating-based coupling schemes, our method basically combines the best of the two worlds with both broadband low-loss operation of edge coupling and high channel density and wafer level testing for the grating coupling. And also we can allow very large misalignment tolerances. So another topic of our research that is also kind of related to the theme today is high performance AR and VR devices that may enable remote working and interaction. Imagine that you are completely immersed in a lightweight AR/VR goggle and your body movement is fully captured with the 3D sensors integrated on the same device. So the better the performance of this kind of AR/VR device, the more details of the remote interactions we can define. So far, there actually are still quite a bit of technical barriers there that need to be overcome to fully unleash the power of AR and VR. So one of the major issues are basically the field of view, and the other one is the image quality from the image projector and the 3D sensors. Basically, for improved performance, it always comes with the increased complexity, size, weight, and cost of the optical systems. So our team have recently actually demonstrated a suite of high-performance flat optical technologies using a new technology called metal surfaces. Basically, this includes the first panoramic fisheye metal lens, which is a flat lens with a required 180-degree diffraction-limited field of view. Basically, for conventional fisheye lenses, they always require multiple lenses stacked together for off-axis aberration control. Our new approach basically using only a single completely flat optical elements with the thickness of only a few millimeters. And it can already achieve high quality aberration-free imaging or image projection into your eye. So while this is still in the early stage, this kind of fisheye meta lens will find wide usage in imaging, 3D sensing, and near-eye displays. So we actually recently published this work, and it also has been spotlighted on MIT News. So these are just some examples of our recent progress that are related to the symposium. I'm sure that we can get more inspirations and foster more collaborations from this event.
Yeah, thank you so much, Tian. So before we move to the questions, I just would like to remind our participants that they can ask their questions to the panelists in the chat box or in the questions box. And also to remind to you that our time is limited, and please respond briefly to the questions. So my first question would be the following. Since COVID-19, how have you reorganized the work of your team or the work of your faculty? Arvind, would you mind to start?
Was that me, Lesia?
No, it was Arvind.
Okay.
Sorry, I didn't hear the name properly. Yeah, so I think clearly everything has become online with respect to classes. And as I said, I'm going to focus quite a bit on the research aspect of things. We've kind of moved all of our meetings online as well, which is not surprising. We have continued to have research seminars and reading groups, which are organized through Zoom meetings. Again, very traditional in some sense, kind of similar to what other institutions have done. Let me just kind of briefly kind of touch on a few things, which is that since our work, and I think Tian and David also have very similar kind of aspects to it, which is very hardware oriented. So the aspect that you have to go and tinker around with device hardware, which means that you need to have personal access to lab, is a challenge. And our school has put in place a lot of processes such that you have to be declared as one of the key personnel if you actually need to have access to lab resources. You have to fill out a form if you actually are going to be on campus for a period of time, so that they can do contact tracing afterwards. So we follow all of the best practices in that sense. So our students go in once in a while. We ensure that if they are actually in the lab, there is at most one student in the lab at a given point in time working on any of the hardware resources. They kind of, it's kind of working okay. I mean, it's not necessarily ideal. So that's some of the things that I would like to share.
David, would you like to add something? Would you like to explain how did it change for you, for your team?
Yeah, certainly. So similar issues, we can only have so many people in the building at certain times. We want to make sure that we're following all the safety protocols that apply locally. And of course, I think a lot of schools and universities, they've really tried to be extra rigorous when it comes to health and safety of students and faculty and so forth. And so we've really been helped by that. Even though our lab is just one of many labs within the university, we benefit from the regular testing, of course, for students and for staff. And I think that's probably similar for most schools and universities across the country. For us, one of the things that was a little bit of a blessing in disguise with this is that when we had to go remote, we realized that, in fact, although there were things that we were doing with hardware, working with individual servers and switches and stuff in our lab, a lot of things that we looked at previously as, hey, wouldn't it be neat if we enabled this to be done remotely, or we used this tool, or we automated this somehow that we never did before because we didn't have to, because we could just handle things, with our own hands in the lab. Now, all of a sudden, there were huge benefits to doing those kinds of things. And so training our students with certain automation software, getting some equipment, even for doing simple things like power cycling products remotely and stuff like that, all things that, we could have done before, but now we had a really compelling reason to. We've gone ahead and done that, and we're really on a path of as much testing. And when I'm talking about testing now, I'm talking about testing products, since that's what UNHI does. As much stuff like that that we can do remotely, we're going to do remotely. So there's actually been a lot of benefit coming from that.
Tian.
Yes, so our research activities associated with experiments and hardware development actually had to be reorganized because of the limited campus and lab access during the pandemic. So right now, actually, MIT is going through a phased ramp-up process across the entire campus that allows gradually increased on-campus activities, for example, to the clean rooms, to our labs and offices. So what we do is that we have to coordinate well within our team and with our collaborators to try to optimize the arrangement of experimental tasks and tools and to perform work that can be reasonably done. So when there was a limited access to certain things, we basically reorganized the tasks by focusing on things that we can accomplish with the most effectiveness. For example, this may include extensive theoretical studies, modeling type work, which are also critical to us, as well as data analysis during the time when experiments cannot be done at all. So being in the academia, there are also a lot of writing and thinking work involved in our daily life. They actually has also been maximized during the challenging times.
Okay, so it seems that everywhere we are adapting to this new environment and doing a lot of remote work and online collaboration. So my next question is around the metrics. So do you plan to introduce any new metrics to measure the efficiency of your team or the efficiency of your personal maybe work? So let's start with Tian, please.
Yeah. So I guess for I have to say that it's not quite easy to quantify the efficiency of research work because innovations and creativity that are critical to us are sometimes very difficult to measure. But what I'm glad so far is that since the beginning of the pandemic, all of our actual team members and collaborators have been highly spirited and motivated as usual. And as a result, we actually maintain our high efficiency, to make progress in research, unless there are uncontrollable circumstances. As I mentioned earlier, that coordination is very important than before. So this actually includes understanding the limit and concerns of the individual person, reassignment of some tasks to improve the efficiency. So I think that to kind of a better coordination will lead to better efficiency as a team.
Okay, Arvind.
Yeah, I completely agree with Tian. It's I think the challenging part in an academic setting really is how do you have proper metrics? I mean, we in general have various evaluation that we do, for instance, examinations that PhD students, for instance, take, or how students do in terms of course evaluations and stuff like that. But it's very hard to be scientific about things which have, in some sense, random noise, which dominates the signal in some sense. As an example, we could measure, for instance, the number of papers a PhD student writes, but that's so much depends on various other aspects that it's really hard to have it be a metric, for instance. Another thing which I think I'm most worried about, and I think that was touched upon by the first speaker, is the well-being of students in a setting where there's very little social interactions. So in fact, every PhD student that I advise, I tell them, the one advice I give them is go exercise, because that's kind of the one thing that you can control, which kind of ends up giving you some satisfaction, and then kind of tell them that's the highest priority, even more than making research progress. So I have to say that I don't have anything specific to say in terms of new metrics that we've been monitoring, but I think it's one of the biggest challenges that we have to deal with in this current climate.
Yes, I definitely agree with you. It seems that we will need to come up with a new metrics. David, what's your input on these measurements and efficiency?
Yeah, so with us, there's a few metrics that we've been paying extra attention to, not so much new metrics, but just things that we were recording before that we want to look at and make sure that we're still reaching the level we were at previous to the pandemic. So important metrics for us would be the number of communities that we've engaged with in a given year or a given quarter, the number of companies that we've engaged with, number of unique companies, the number of new test services that we've provided. A very important one for us is the number of our students that we've placed in industry. You know, are we preparing them properly to go into industry and be effective there? So those are things that we've always kind of tracked as metrics of success for our lab. One thing that we've been paying kind of extra attention to, and I think this maybe is unique to University of New Hampshire InterOperability Lab, but I think lots of folks will relate to this. Our product oftentimes is test reports about things that we run tests on. And so in order to make sure that we're still operating at a high level and that we're still operating efficiently, we want to make sure that we're putting out as many test reports now as we were previously. So that's a metric that we've been paying a lot of attention to. Given that we have less people in the lab, the way we've worked has changed. If that number of test reports starts to go down, well, we need to change something about the way that we're working. And so that's a really important metric that we're paying attention to as well, to make sure that we're just simply accomplishing as much as we were before.
Yeah, thank you so much for sharing. I think it's wonderful because right now we have some key performance indicators that we can use for developing the future metrics. So I would like to ask my last question before we move to the Q&A session. With this remote collaboration going mainstream, how do you plan to make a transition to remote or maybe a hybrid types of work in your organization or university? David.
Yeah, so understand again, for me, I'm talking just about the IOL, the InterOperability Lab, which is one lab within University of New Hampshire, and we're definitely taking the approach that as much as can be done remote, we want to do remotely, and that's paying off. It's giving us a lot of benefits in terms of flexibility, especially with our students. So our organization is about 120 persons. A lot of those are engineering and computer science students. And so giving them some flexibility to work around their academic schedule has always been critical to our mission. And so the more we can do remote, the more flexibility we're giving to our students. It's interesting for us, we actually moved our lab facility maybe 2 or 3 years ago. Previously, we were off campus. Students had to take a short bus ride to get to our lab. And a couple of years ago, we moved to be right on campus where students could walk from class, walk from their dorms, and so forth. And even that gave our students such a boost. It made it so much easier for them to come into the lab and do work. So we got a lot of benefit from physically being closer. Physical distance isn't so important anymore, but the ability to do the work flexibly and remotely for our students is very important. So we're seeing a lot of benefits there. The flip side of that is that we don't want to make it so easy and put so much demand that it starts to interfere with our students' academic coursework. So those are certainly things that we're trying to balance, but at its core, we're trying to do as much remote as we can.
Yeah. Tian, would you like to share what's your perspective on that?
Yeah, so I concur that a lot of things will be changed, for the long term. As I mentioned, that coordination, plan, and communication will be essential in future remote collaboration and working. For example, since the start of the pandemic, actually we have had our team members who were affected by the travel limitations due to the emergency and had to work remotely actually in another country for not a very short period of time. So what we did is that we hybridized, from a team perspective. So we retailored the team members' tasks and coordinate with other team members so that we could continue moving the project forward while keeping everyone at their optimal status with the resources they could get access to. Also, I want to mention that a good amount of academic work involves writing, brainstorming, and communication. For example, I may have a collaborator or a co-author on a scientific paper that are located on the other side of the globe. Maybe someone I've never seen before in person. But we can still work together, brainstorming, writing articles, using the existing online documentation tools. This model is actually not uncommon in academia, even before the pandemic. And I think that it will be further enhanced with new online virtual tools. And similarly, a lot of the conferences have gone virtual nowadays. Online presentations and meetings will become the normal. And we're also getting adapted to that, to interacting with folks around the globe. And I think the last point I want to raise is that in addition to all the technical challenges we have been facing right now, there are also personal challenges that our team members have to face individually. So for the long term, we also need to offer our full support and flexibility on everyone's work. For example, schedule and priorities, so that we can maintain a fully open communication channel to better understand everyone's concerns.
Yeah, thank you so much. Arvind, real quick, do you have something to add before we move to the Q&A?
Yeah, just want to maybe touch upon a couple of things which David and Tian already touched upon, which is that there are a couple of really positives which have come out of it. One is that I'm organizing this a workshop on programmable device hardware at the end of this month at University of Washington, and I currently have people lined up from Australia, Hong Kong, Switzerland, people who would not necessarily make a trip, and now they can just be on, give a talk, and that's fantastic. Similarly, we have these huge program committees which kind of decide paper acceptances into conferences such as SICOM and NSDI, the top tier kind of networking conferences. Now, all of the program committees are online, and actually, it just you don't have to travel for a day and a half or 2 days to get to some place and just do it. So it just kind of streamlines a whole bunch of things. And the last bit that I want to add is that I think the social interactions, and as well as having random technical interactions, which you just bump into someone or someone working in the lab just across from your desk, those are the hard things to actually kind of provide in this setting. And we are trying to experiment with apps such as Gather, where you it kind of gives a virtual space and you kind of walk around and you kind of mill around with people and kind of ask questions and answer, just kind of have these random chats. And our hope is that that will help a little bit. And, that is the piece which is still a big challenge.
Thank you so much. So I would like to invite Dirk, who will be giving some questions from a Q&A. Dirk?
Hi, thank you. Great discussion so far. We've got a couple of really good questions. And so the first one that I'd like to pose to the panelists is, seeing companies like NVIDIA with Project Maxine utilizing AI-based meeting optimization tools and lower bandwidth, which makes meetings more bearable, is this something that the panel members are looking at?
Who would like to answer this question?
Yeah, so I guess I'm going to go first. I think the online video capabilities with lower bandwidth is going to be very important. So nowadays, basically, we have seen conferences, meetings. Sometimes you can go without the video, but for a lot of remote type of work, for example, if we want to work something in the lab and you need some help or assistance from your collaborators. Under the current setup, actually, we only allow a limited number of people sitting in the lab. So that means this kind of remote assistant type technology advancement will be very important. Yeah.
And David Woolf was smiling, so maybe we'll let him answer as well when he heard the question.
Yeah, well, the thing that struck me is that I think all of us, everybody's spending time on these tools, hours a day on a WebEx or a GoToMeeting or a Zoom, and we would love to see these tools improve and become more versatile. I can't say that it's an area of research for me, but I think that the idea of, especially for those of us working in research labs or working in areas that require some hands-on interaction, whether it be plugging and unplugging things or any other number of things that just plain need to be done manually, the ability to integrate that into conferencing tools is quite attractive. But like I said, I can't say that it's an area that I'm actively working on.
Arvind, would you like to add anything?
Nothing more than what Tian and David has talked about. Yeah.
Okay. The next question is, have you seen any experiments go better since maybe ambient physical interferences are no longer there? Anyone?
Seems like a difficult question.
Well, I think I could say a couple things about that. Short answer, yes. It's funny that so many of the mistakes that happen in the lab are human error, and so literally having less people in the lab, things are less likely to be unplugged inappropriately or things like that. I think we've all experienced that. There's extra thought that goes into setting up, for me, test runs, what might for some of my colleagues be experiments. Extra thought goes into that if you know that you will not be back in the lab to fix it, or that there's a certain hurdle that must be met to come back in the lab to fix it or run it again or things like that. So we see people putting more thought into those things so that they run a little bit smoother without any human interaction or what you could also call human interference. So yeah, I do think there's benefits there.
Okay, Arvind, you agree? You were nodding your head.
No, I see a lot of value in what David is saying, but unfortunately, I don't think we have seen that happen in our place. It's mostly, I think we still are. Maybe I think there's a certain sense of, the kind of problems that we're running into is, we kind of put in the wrong NIC, for instance, on the server, and we don't quite know what the NIC is. Or you have to have a student go in and kind of take a check out, which means the experiments take 48-hour cycles as opposed to like 1-hour cycles. So we're still grappling with those challenges. So we haven't see the positive side, but I can imagine what David's saying could play out.
Okay, great. I think we have time for one more question, Lesia, and then we'll go to the next discussion. Alan has already graciously agreed to cut his section a little bit shorter. So the last question is, how are the three panelists interested in engaging with the OCP Symposium members after this event?
That's a very good question.
So I'm going to ask it of everybody. Tian, you want to go first on this one?
Yes, sure. So I guess we can release more information about some of the related technologies that I've just been talking about, and just looking forward to further discussions for anyone that are interested.
And just a reminder that we've set up a LinkedIn page for the time being that we can all go in and interact with. And so if anybody has any questions that were unanswered, or if they'd like to pose more questions to the community, put those out there. We'll be moderating it. And if we need to get a direct answer from somebody, we can manage that. David or Arvind, did you want to answer that question as well?
Yeah, happy to engage on LinkedIn conversations. My website and email is also linked from my LinkedIn page. In general, we are very open to kind of research collaborations also, in addition to understanding how to deal with sort of this pandemic response. So happy to engage in any fashion.
Great.
Yeah, likewise, I would say engaging on LinkedIn, happy to do there. And I think for each of us, our areas of work and research, there's a lot of overlap with what OCP is doing. So I think all of us are certainly interested in engaging with the different work groups. And if that happens through LinkedIn and Future Technology Symposium, that's great.
All right, great. And I'll post the link in the chat boxes and in the Q&A as well for people so they can join the LinkedIn group.
Perfect. Thank you so much for this wonderful panel. We had more questions that we were able to address, but we will follow up in the LinkedIn page and maybe organize in working groups and virtual sessions next year.